Welcome to The Explainer. Today, we're taking a look at Google's brand new AI, the Gemma 4 family. And what's so cool about these is they're not just these massive, powerful models. They're a peek into a future where cutting-edge AI can run right on your own devices. So let's dive right in. We're talking about a new generation of open models called Gemma 4, and the big deal here is that they're both super powerful and really, really efficient. Just think about that for a second. I mean, state-of-the-art AI that's not stuck in some huge, far-off data center, but can actually run right on your phone or your laptop. That's exactly what Gemma 4 is all about. All right, so what exactly is this new family of models? Let's get introduced to the members and kind of break down what makes each of them special. So this family has 4 different models, and each one has its own specific job. You've got these smaller, more nimble E-models. Those are the ones designed to run on device, like on your phone. And then you have the big guns, the 26B and 31B models. These are the powerhouses built for your workstation, ready to handle the really tough stuff. The key is each one has its own special architecture that's just perfect for what it's designed to do. Okay, so what makes these things so special anyway? I mean, what can they actually do that's different from what we've seen before? Well, it's really the sheer range of things they can do that's so impressive. We're talking about building agents that can actually go and complete tasks for you. AI that can understand and reason about not just text, but images and audio too. And get this, it can do it all in over 140 languages. This is a massive step forward in making AI that's, genuinely useful and flexible. And you know what? This isn't just hype. The numbers really do speak for themselves. I mean, just look at the huge jump in performance from the last generation, Gemma 3, over to Gemma 4 on these standard benchmarks. When you look at stuff like math and coding, wow, the improvement is absolutely staggering. This is not just a small step up, it's a genuine quantum leap. So the big question is, how does Gemma 4 pull this off? How is it so powerful and so efficient at the same time? Well, it all comes down to some really clever architectural decisions. You could call it the secret sauce. So the models do this really smart thing where they mix 2 different types of attention. First, you've got local attention. Think of this as the fast, efficient one. It's like talking to someone who only really pays attention to the last few words you said. Then you've got global attention. This one is like someone who remembers the entire conversation from the very beginning to understand the full context. But of course, that's a lot slower. Gemma 4 gets the absolute best of both worlds by smartly jumping between the 2. And this quote right here, it perfectly explains why you can't just rely on that fast, local attention. If you don't zoom out once in a while to get the big picture with global attention, the original message can just get lost along the way. Yeah, exactly like a game of telephone. Okay, but what about images? How does it see? Well, Gemma uses a really cool technique from something called vision transformers. It basically takes an image, chops it up into a bunch of smaller patches, kind of like a puzzle. Then it turns each little patch into a string of numbers, an embedding, and then it just reads that sequence of numbers like it's a sentence. It's a really brilliant way to teach a language model how to see. Right, but that super powerful global attention, it's still really, really expensive to run. It takes a ton of computing power. So the engineers came up with some brilliant tricks to make it way more efficient. You can think of them as clever shortcuts to get the same result but with way less work. And these tricks slash the amount of memory you need without really hurting performance. And one of the cleverest of these tricks is called probe. Okay, so imagine you're reading a sentence. Part of understanding it is knowing the order of the words, their position, right? And the other part is knowing what the words actually mean. Well, probe does this amazing thing where it separates those 2 types of information. This lets the model really focus on the meaning, the semantic content, without getting all bogged down by the word order. And this becomes super, super useful when you're dealing with really long, complex pieces of information. So when you put all these clever architectural tricks together, you get a family of models where each one is perfectly designed for a specific job. Let's take a look at how that actually works. Okay, take the 26B model. It uses something called a mixture of experts architecture. Now, instead of having one single giant brain trying to do everything, think of it more like having a whole team of specialist doctors. When a problem comes in, the system is smart enough to send it to the exact experts who are best at solving that specific kind of problem. And we're not talking about a small team either. The model has a pool of 128 of these specialized experts ready and waiting to be called on. But here's the real magic. This is the key to its efficiency. For any one task, it only activates 8 of those experts. So even though the whole model has 26 billion parameters, it runs with the speed and efficiency of a much, much smaller model. Why? Because it's only using a tiny fraction of its total brain power at any given moment. Pretty clever, huh? Now, the smaller E models, they use a different trick to stay efficient on your devices. It's called per-layer embeddings. The best way to think about it is like this. Imagine your desk is your fast, expensive RAM. It's small, right? You can't keep all your books there. So instead, you keep most of your books on a big bookshelf. That's your flash storage. You only grab the exact book you need and put it on your desk when you need it. This is an absolute game changer for running powerful AI on things with limited memory, like your phone. So what this all boils down to is 2 different approaches for 2 different needs. You've got the E-series models, which are all about max efficiency on things like your phone or other small devices, and they can even handle audio. And then you have the big 26B and 31B models, which are built to bring that really cutting-edge AI power right to your personal computer for the heavy-duty work. Okay, so we've covered the what and the how, but let's talk about the so what. What does all this actually mean for the future of AI? Why should we care? Why is this such a big deal? If there's one thing to take away, it's this. You're getting an unprecedented amount of intelligence for the size of the model. Gemma 4 packs a ton of reasoning power into a package that's efficient enough for lots of people to actually use. It basically breaks that old rule that said to get smarter AI, you need a bigger model. Not anymore. And that accessibility, that's really the key here. This puts truly powerful, state-of-the-art AI into the hands of developers, researchers, even students, letting them run it right on their own machines. And that means, faster development cycles, much better data privacy, and the power to build amazing apps that can work completely offline. And really, that brings us to the most exciting question of all, the one these models are asking every single one of us. It's not just about what a few giant tech companies can build in their massive data centers anymore. Now, with this kind of power running on your hardware, the real question is, what are you going to build?